Right, everybody in AP Stats. Today we're going to go through a significance test for proportions. So just like Panic, we've got a specific write-up. If you follow the write-up, you get full credit. This is what we're basically looking for. So let's go through a problem together. It says on TV shows like American Idol, contestants often wonder if there's an advantage to performing last. To investigate that, researchers selected a random sample of 600 college students and showed each student the audition video of 12 different singers. For each student, the videos were shown in random order, so we would expect approximately 1/12 of the students to prefer the last singer they view, assuming the order doesn't matter. In this study, 59 of the 600 students preferred the last singer they viewed. Do these data provide convincing evidence at the 5% significant level that there is an advantage to going last? All right, so when we read these, the reason that I know it's a test is that they are asking me a yes or no question. It's right here. Do these data provide convincing evidence? Yes or no? Okay, if they were asking for you to come up with a proportion and guess at a proportion, then you would be doing a confidence interval. All right, so once we know that we are doing a test, we are going to be following the letters of phantoms. Now you notice that a lot of these letters also spell panic. Okay, so 3 of those are still a repeat, and a couple of them are very similar. We've just changed the letter slightly. Like the conclusion statement is now like the summary statement. Okay, so a lot of these are still panic. We're just adding in a few more steps. So here we go. So the first one, just like usual, is we're going to describe what the population parameter is. And then the second one is we're going to write the hypothesis statement. Now, for some reason, I'm usually more comfortable doing the hypothesis statement first, is I know that this is a proportion. So I'm going to be doing that I believe the true population proportion, hold on, let me write null hypothesis, alternative hypothesis. I believe, or they stated that the true proportion is 1/12. And then they're asking me, do we have convincing evidence that there is an advantage? If there's an advantage, then that proportion would be greater than 1/12. Notice we are using population because, again, we're trying to make a decision about what we think is happening in the true population. All right, so up here would be then where I would identify what that variable is. So I would say P is the true proportion of students that prefer the last singer. All right, so very similar to what we were doing in panic processes, and we've been practicing the null and the alternative hypothesis. All right. So next on to our next set is going to be A and N. So A is our assumption, so we still have the main 3. Do we have something about random? Do we have something about 10% rule? And for proportions, can we assume that we are normal? So in random, I'm going to go back to the problem, and it looks like videos were shown in random order and they randomly selected. So we've got 2 different things of random we can mention here. Students were randomly selected and videos randomly assigned. Okay, randomly assigned to be shown. Okay, 10% rule, this is the one about 10 little n and big N. So we want to make sure that what we are sampling is less than 10% of the entire population. We looked at 600 students, so I would say it is reasonable that there are more than 6,000 students. And then normal, remember, changes whether it's a proportion or means problem. In our case, it's a proportion problem. So we're doing NP has to be more than 10 and N1 minus P has to be more than 10. All right, so our sample is 600. our proportion is still going to be the population. That's the null hypothesis proportion that we're using in here, because we're trying to show that that null hypothesis is true. So we are doing 1/12 has to be more than 10, and 600 times 11/12 has to be more than or equal to 10. All right. So if I do this one, I'll get 1/2. I'll get 100/2. That is 50. We're okay here. And that means this side should be 550. And we are okay there. So we can assume our distribution is approximately normal. All right. And then N is going to be the name of the test that we are performing. So in this one, we are doing a one sample proportion Z test instead of interval for population proportion. So let me fix that. Let me put that up near the top. One sample population proportion. That's a Z test. Cool, that should work. We don't have a percent for a confidence interval there, so we're good there. All right, so there's that too. Then the next one we're gonna do is the mathy section. So our mathy section is up next. That is under T for phantoms. That is gonna be our test statistic. So test statistic in this case, is going to be a Z, right? So in this case, remember when we calculate Z-scores, we would do Z equals, and we would do our amount minus the mean amount divided by the standard deviation of the type. So in this case, we are going to have to figure out what P hat is minus P over the standard deviation of P1 minus P over N. Okay, so off to the side here, we're going to go figure out what our proportion was, and they said we had 59 out of 600. Okay, so 59 out of 600 into my calculator that goes. And that gives me a 0.0983. Okay, so when I do my Z calculation, we're going to be doing 0.0983 minus their 1/12. So 1/12, if I turn that into a decimal, your choice whether you want to or not, 0.0833. And then we're going to go and create the standard deviation underneath. Now underneath, remember, if we have the population proportion, the null hypothesis proportion, that's the one we want to use. So this is going to be the 0.0833, 1 minus 0.0833 over 600. Okay, going to calculate that out, come up with a Z-score. So the Z-score I'm going to get on this one is about a 1.33. Let me go and see if I can get one more decimal on this one. So 1/12, 59 over 600. It's like a 1.3293. Okay, 29. Cool. All right, so there is my test statistic. Okay, the next step is we're going to obtain our p-value. Okay, so the next step is we're going to obtain our p-value. So these two are new steps that we haven't been practicing before. So obtain our p-value. Okay, so this is going to look familiar. We're going to go and draw our normal curve. We're going to go and put, this is a Z-score, right? So this is where Z is 0. This is where Z is 1.329. And we're going to go and look at our alternative and color in the direction they want, so greater than. So I'm going to be coloring in this side. Okay, and then the very next thing we're doing is we are going to calculate that probability. So we're going to say, what is the probability that the Z-score is greater than 1.329? And that's going to be norm CDF from 1.329 to infinity when the mean and the standard deviation are 0 and 1. So that's our next step. All right, and the probability that I get is 0.0919, so about 9%. So that is our p-value. So p-value. The last thing we want to do in this step is not only just draw this, we want to say that z is approximately normal with a middle of 0 and a spread of 1. Okay, in this case. Cool. All right, on to the next step, which is we're going to now make a decision based on our p-value, and we're back to stuff that you are comfortable with. So M is make a decision. So the first thing you're going to do is you're going to compare, and you're going to say because the p-value, which was 0.09, is less than or greater than the alpha level. So here is our first time looking for the alpha level. So going back up to the top, we find out that this is a 5%. So this is greater than, right? So because our p-value is greater than the alpha level we set, we have not made it secure enough. We have not made it past the border of smaller than our alpha level. So because it is greater than, we fail to reject HO. All right, so writing that down, writing down the alpha level, I have realized that I have never written it before this. That's probably not a good plan. So maybe a good place to put this would have been a one sample population proportion z-test at a alpha level equal to 0.05. That would be a good place to put it. Because remember, that's supposed to be set before we start, so we're just acknowledging that it's there. All right, and then the last one, S, is a summary statement in context. So we're going to say, what does it mean to fail to reject the null hypothesis? How does this relate to students viewing all these videos? We're going to say there is not enough convincing evidence that the true proportion of students who prefer the final singer, is greater than 1/12. Greater than 1/12. So there's not convincing evidence that there's an advantage to performing last. There is no advantage to performing last. So notice the first sentence in M is just talking about the numbers. It's going to look almost the same every single time. Compare your p-value to your alpha level. If the p-value is higher, you fail to reject. If the p is low, then the null hypothesis must go. We're going to reject the null hypothesis. Okay, and then the summary is always about tying it back in. Also notice here that I mentioned that it's greater than 1/1/12, which was the alternative hypothesis, right? So when I'm explaining it, I'm saying we do not have enough evidence because we failed. Okay, so we don't have enough evidence to actually show that it really is greater than 1/12. Awesome. That's all there is to it. Pretty easy, right? All right, so I've added a few more things. The very last thing we're going to talk about, the big one was just how to do a significance test for proportions. Okay, the second thing that we want to do is describe the errors, and we've been talking about this ahead of time. So remember, a type 1 error is when we reject the null hypothesis incorrectly. We actually did make the decision that could cause a type 2 error. We failed to reject HO incorrectly. So if that were to happen and we'd find out later we were wrong, then that would be saying that there was a preference for the last singer, but our data led us to failed to reject the null hypothesis. Okay, so that's why we're only really talking about a type 2 error in this one, is because that matches our decision. Okay, what would happen? What would be the repercussions of that? Well, really, it's just singers who would say, we just showed them that it doesn't matter what order they're in when it really does. So singers now don't care what order they're in, or maybe they should have fought for being the last singer of the day or in the group that they are performing in. And then the last thing we want to bring up today is the word power. And power is an actual calculation. It's 1 minus beta. Remember, beta is a type 2 error. And another way you can think about power, it is the probability against making a type 2 error. So in this case, we don't know what the actual probability is. We just know that the power of this test that we did would be everything but that probability of making a type 2 error. Remember that our alpha level up here, that was our alpha level, right? We're talking about a beta level at this point, which is a different number, and it's not provided within the test. So if they told me what the power level is, I could tell them what the type 2 error probability is. If they told me what the type 2 probability is, I could tell them what the power is, okay, that those are related to each other. All right, that's it for today.